Hello everyone, welcome to Let's Learn Forever. Today I am gonna solve some problems of unit and dimensions that I have discussed earlier. So let's get started. So in our first question, find the dimensional formula of the following quantities. The universal gas constant of gravitation G. We know that F is equals to G m1 m2 divided by R square, where m1 and m2 is the masses of two bodies and R is the distance between them. That implies G is equals to F into R square divided by M1 and M2. And from this we will derive the dimensional formula of G. The dimensional formula of G will be the dimensional formula of force or F into the dimensional formula of R square, that is L square, and divided by the dimensional formula of M1 and M1 into M2, that will be M square. That is equals to the dimensional formula of F is m L t minus 2 t to the power minus 2 into L square divided by M square. That is equals to m to the power minus 1 L cube into t to the power minus 2. So this is the dimensional formula of universal constant of gravitation G. Coming to the next problem. The surface tension S. Then the S is equals to rho G R H divided by 2. Rho is the density. So the dimension of S will be dimension of rho, dimension of G into L square, because R is the dimension of L and H is the dimension of L, because H is the height and R is the radius, that will be L square. So dimension of rho is m divided by L cube and into L divided by T square G and L square, that will be m t to the power minus 2. This is the dimension of surface tension. Here I have written the dimension of rho is m divided by L cube. This is because density mass for volume. The dimension of volume is L cube. So coming to the next problem. Here it is asking how many ox are equal to 1 joule. So we know that the SI unit of energy is 1 joule and the CGS unit of energy is 1 erg. So I am writing them on my screen. CGS unit of energy is erg. So we know that dimensionally energy is equal to mass into square of velocity. Then mass will be what? Mass and velocity will be the length by time and its whole square. Length divided by time whole square. And the dimension will be then m L square t to the power minus 2. Thus 1 joule will be what? 1 joule will be 1 kg into square of 1 meter into 1 second to the power minus 2. Similarly, 1 erg will be 1 gram into square of 1 centimeter into 1 second to the power minus 2. Now 1 joule divided by 1 arc, that is equals to 1 kg divided by 1 gram into 1 meter divided by 1 centimeter whole square into 1 second divided by 1 second to the power minus 2. 1 second divided by 1 second will be cancelled out, and 1 kg will be 1000 gram divided by 1 gram into 1 meter will be 100 centimeter. That will be 100 centimeter by 1 centimeter to the power whole square. That will be 10 to the power 7, because gram will be cancelled out and centimeter will be cancelled out. So therefore 1 joule will be 10 to the power 7, or this much is our answer. Next question is, if velocity, time and force were chosen as basic quantities, and find the dimension of mass. Uh, in the previous lecture, I have discussed about some fundamental units where mass was the fundamental unit and velocity and force were the derived units. But here in the questions, it is said that velocity and force are the fundamental units, and we have to derive mass from them. So see how I am doing this, solving this problem. So dimensionally, we know force is equals to mass into acceleration. It is what? Newton's law. Mass into acceleration. F is equals to ma. So then acceleration is what? Velocity divided by time. So mass will be what then? Force into time divided by velocity. Velocity. Therefore, the dimension of mass will be what? Dimension of force into dimension of time into V, dimension of V or V inverse. And here in the question we have given that velocity and force and time are the fundamental units, and we have expressed the mass in the terms of those fundamental units. So this is the last problem. In this problem, if the centripetal force is the form of m to the power a, b to the power b, and r to the power c, it is asking to find out the values of a, b, and c. So we know that centripetal force is also a force, and the force, it is a force since its dimension will be the centripetal dimension of centripetal force will be the dimension of force. It is given that in the question force is mass to the power a, velocity to the power b, and length to the power c, or r to the power c. So now writing the dimensions of this equation will be what? M for dimension of force is m l t minus 2 t to the power minus 2. Dimension of force is mass, that is m to the power a, that will be, and the dimension of velocity will be l t to the power minus 1, so that will be l to the power b and t to the power minus b, and length will be l to the power c. Then that will be m to the power a, l to the power b plus c, and t to the power minus b. So as I have discussed in the previous lecture, we can equate this equation now. Equating this, we will get a is equals to 1, b plus c is equals to 1, and minus b is equals to minus 2. Sorry, minus b is equals to minus 2, or a is equals to 1, b is equals to 2, and c is equals to minus 1, or f is equals to, we will get mb square by r. So finally we got the values of a, b and c. This is how we can solve our problems. You can solve your problems from your textbook, and if you have any doubts, you can put the doubts, you can ask them in the comment section. I will be happily answer them. Thanks for watching. See you in the next video.